Hey everybody. Today we're doing a harder example testing a function for continuity at a point using the limit definition. Here's the problem that we're going to do. We want to determine values of a and b that make this function continuous at x equals 2. Now this is a piecewise defined function, and x equals 2 is the Frankenstein point. It's the value where the different pieces of this function are stitched together. So in order for this function to be continuous at x equals 2, we're going to need the value of the function to equal the limit as x goes to 2. And in order for that limit to exist, we need both one-sided limits to exist and to agree. So basically, testing for continuity here amounts to getting both one-sided limits, making sure that they're both equal to the value of the function at x equals 2. Here it is written in symbols. Now let's take out f and replace it with what it's equal to. So for example, as x goes to 2 from the left, x is less than 2. So f of x is equal to x squared plus 7x minus 18 over 2x squared minus 8. Similarly, as x goes to 2 from the right, f of x is equal to a minus 2x because x is bigger than 2. And f of 2, of course, is just b. So I have a three-way equality here. The strategy is to evaluate these limits and then set everything equal and try and solve for a and b. So let's jump right into it. Let's do the right-hand limit first. I think that's the easier one. We're looking at the limit as x goes to 2 from the right of a minus 2x. Now, a is just some number here. We don't know what it is yet, but it's just some number. So here we have a polynomial. And polynomials have the direct substitution property, so I can take out x and plug in 2. So the limit from the right is a minus 4. The limit from the left takes a little bit more work. In this case, we're looking at the limit as x goes to 2 from the left, x squared plus 7x minus 18 over 2x squared minus 8. And if I plug in 2 to the top and bottom, I'm going to get 0 over 0. An indeterminate form, I know I'm going to need to do more work. I want to factor the top and bottom, like so, and then cancel the common factor of x minus 2 from the top and bottom. Now I have a rational function where 2 is in the domain, and I can just plug in using direct substitution. Overall, I get 11/8. So we said we were going to equate the three things. F of 2, limit as x goes to 2 from the left of f of x, and the limit as x goes to 2 from the right of f of x. Doing all that, I get these two equations. A minus 4 is 11/8, and b is 11/8. Therefore, a has to be 43/8. Plugging those back into my original function, here's what I have. I've taken out b and put in 11/8, and taken out a and put in 43/8. Now my contention is that this function is going to be continuous at x equals 2. I've showed that already. Let's verify it by looking at the graph. Here it is. We can see that at x equals 2, the limit from the left of f of x is equal to the limit from the right of f of x, which is equal to f of 2. This function is continuous at x equals 2.